Good morning, students. Assalamu alaikum. How are you all? I hope you are well by the grace of Almighty. Me, Mohammad Jahid Hassan, Assistant Teacher, Milestone School and College, Sector 30. Today, I am going to take your science class. Before starting today's topic, we will take some feedback from the previous topic. Our first question from previous topic. Describe different layer of atmosphere. There are four layers of the atmosphere, and they are troposphere, stratosphere, mesosphere, and the thermosphere. Troposphere. Up to 11 kilometers from the Earth's surface is troposphere. Most of the essential gas like oxygen, nitrogen, carbon dioxide, and water vapor are present in this layer. That is why troposphere is the most important layer of the atmosphere. From just above the troposphere, stratosphere starts, and it is extended up to 39 kilometers from the Earth's surface. This layer contains one of the most important gas named ozone, which protects us from the sun's harmful ray. Third layer of the atmosphere is mesosphere. This layer starts from where stratosphere ends. With increase in height of this layer, temperature start falling. Fourth layer of the atmosphere is thermosphere. This is the last layer of the atmosphere. And this layer is almost airless. That means vacuum. In this layer, temperature rises fast, so it is called thermosphere. Radio signals are reflected from this layer. Our second question from previous topic is why Padma river is so big? And the answer is the Himalayan range of mountain is situated to the north of our country. A huge amount of ice accumulates on the top of this mountain range. When this ice melts, waters come down alongside the mountain and a narrow river is created. This river becomes wider when more water is added to this. There is excessive rainfall in Nepal, India, and Bangladesh. The rivers created in the Himalayan range responsible for bringing this rainwater. So the rivers like Padma is very large and wide. Hopefully you have understood the answer. Third question from previous topic. Explain how universe was formed by a vigorous explosion. Scientists assume that before crores of years, a lump of small but heavy and hot body exploded vigorously and scattered in all directions. This explosion is called the vigorous explosion. After the vigorous explosion, a very small particle of the substance was converted into minute particles. Then this minute particle became a cool and came together to form an astronomical body. In this way, the sun and other stars were created. The energy, matters, space, everything of the universe is created from this vigorous explosion. It is assumed that when the sun was created, then its remaining portion of small particles was floating in the space like dust particles. After that, these dust particles came together and the earth was created about 4 billion years ago. This is the answer of question number 3. Question number 4 from previous topic. Why atmosphere near the earth's surface is compact? Dear students, do you know what is atmosphere? The gaseous part that encircles the earth is called atmosphere. Atmosphere is mainly composed of nitrogen and oxygen. Besides, there are moisture, dust particles, argon, carbon dioxide, and some more other gases. The earth attracts everything towards it due to the gravity. And due to this gravity or the attraction, gases of the atmosphere remains near the earth's surface. That is why atmosphere near the earth's surface is compact. Now students, look at the last question from previous topic. Why do we need oxygen cylinder while climbing up a mountain? The case of taking oxygen cylinder at the time of climbing mountain is discussed below. The segment which is surrounding and covering the Earth's surface is called atmosphere. And our atmosphere is mainly composed of nitrogen and oxygen. There are some other gases of the atmosphere, and they are water vapor, dust particles, argon, carbon dioxide, and some more other gases. And we all know that due to the attraction of our earth, which is called gravity, the gases of the atmosphere remain close to the earth's surface. So the atmosphere near to the earth's surface is compact. If we go above the earth's surface, the higher we go, the lighter and thinner will be the atmosphere. As a result, amount of oxygen also decrease. So that it becomes very difficult to breathe due to the lack of oxygen. Therefore, we need to take with us oxygen while climbing up the top of a hill for our respiration. Hopefully, you have understood the answer of this question. Students, now move on to our today's topic. Our today's video classwork number is 37, chapter 12, Origin and Formation of the Earth. From this chapter, today we are going to discuss on lesson 7, the internal formation of the earth, and lesson 8, plate tectonic, volcanic eruption and earthquake. What will we learn after finishing today's topic? After finishing today's lecture, students will be able to explain internal formation of the earth, volcanic eruption, earthquake, and the plate tectonic theory. At the beginning of today's topic, we will learn about the internal formation of the earth. The interior of our Earth is divided into three layers, and they are lithosphere, mantle, and the centrosphere. Lithosphere. Below the Earth's surface lies the solid layer covering the interior portion of the Earth is known as lithosphere. The lithosphere may spread up to 100 kilometers below the Earth's surface. Second portion of interior Earth is mantle layer. In the middle portion of centrosphere and lithosphere, there is mantle layer. Major portion of this mantle layer is solid, but some portion of it is semi-liquid or half-melted state. Scientists assume that melted lava spring out by volcanic eruption from this portion. Third layer of internal Earth is centrosphere. The spherical layer of about 3,500 km radius from the center of the Earth is the centrosphere. The another name of centrosphere is core. There are heated nickel, iron, lead, etc. are in the centrosphere. They are in solid state in the outer side and in melted state in the inner side of the centrosphere. These are the internal formation of our Earth. Dear students, hopefully you have understood the internal formation of our Earth. Now students, we will learn about the plate tectonic theory. The basic conception of this theory is based on the finding that the lithosphere below the Earth is separated into many portions or parts. These portions or part below the Earth is called plates. These plates are in floating condition over a region of mantle zone. These plates are displayed by few centimeters per year toward any direction. Sometimes these plates move away from one another. Again, sometimes they come too close to one another. Even sometimes plates move up or down by few millimeters per year. Where one plate come in contact with another plate, then that area become more prone to earthquake and volcanic eruption. If there are high hill or mountain in the areas where these plates are connected, occurrence of earthquakes and volcanic eruption are more likely to happen in those places. It is assumed that when these plates smack or strike on another, immense of heat is produced and the substance inside the earth get melted due to this excessive heat. This melt substance gases out from below the earth's surface due to the high pressure. This split, melted, and hot liquid are known as magma. Students, here you can see some image of some natural disaster. This natural disaster like earthquake, volcanic eruption can be explained through this plate tectonic theory. Hopefully, you have understood this theory. Now we are going to enjoy a video on plate tectonic theory for better understanding. Let's enjoy.
The Earth is a remarkable piece of real estate, and a busy one at that. From ever-changing weather patterns to the hustle and bustle of city streets, our planet is in a constant state of motion. However, if we take a look just below the surface, we find that things are always moving below our feet as well. It's called plate tectonics, and it's how the continents were formed and reformed and reformed. But before we get to that, let's dive underground to learn what our planet looks like from the inside out. Our Earth is made up of layers, and there are two types of layers we need to learn about in order to understand plate tectonics: the compositional or chemical layers and the mechanical layers. We could spend an entire session on what makes both of these types of layers unique, but for this lesson we're simply going to provide an overview. There are three primary compositional layers to the Earth's surface, and these are probably the ones you're most familiar with: the crust, the mantle, and the core. It's important to understand that the compositional layers refer to the materials or elements the Earth is made of. However, if we take a look at how the inside of the Earth behaves, we can divide them even further into mechanical layers. Starting from the outside working in, the lithosphere is the outermost layer of the Earth, which contains the entire crust and the topmost layer of the mantle. The asthenosphere contains the same materials as the top layers of the mantle, but the pressure and the heat are increased. It's not exactly a liquid, but it does move like heated rock, so you could say it's somewhat fluid. The mesosphere is next. At this level, the pressure is really starting to build, which restricts the molecule's ability to move, thus making it very, very rigid. Past the mesosphere is the liquid outer core. Extremely high temperatures melt the metals contained in this layer into liquid form. Think flowing rivers of lava, and you'll have a pretty good idea of what the outer core is like. And finally, we reach the solid inner core. Just like the liquid outer core, the inner core has extremely high temperatures and is composed of mostly metals, which might lead you to ask, why isn't it liquid as well? The answer is pressure. There's so much pressure at this depth that even though the temperatures are beyond the melting points of the metals contained in the inner core, the high pressure essentially squishes everything down into a solid. Now that we know a bit more about the composition of the Earth, let's move on to plate tectonics. Let's start with the history. In the early 1900s, a scientist named Alfred Wegener noticed that the coastlines of several continents looked like they fit together, similar to puzzle pieces. He believed that around 200 million years ago, all of the continents were joined together in one large supercontinent that he called Pangaea, which is Greek for all the Earth. Over the course of millions of years, Pangaea broke apart into the continents we know today, a process he called continental drift. Although his theories explain quite a bit about the origins of the Earth, scientists at the time weren't exactly impressed and initially dismissed his ideas. Fast forward to today, and Wegener's concepts are the basis of the modern-day plate tectonics theory. So what exactly is the plate tectonics theory? Well, it states that the Earth's outer mechanical layer, the lithosphere, is divided into large continent-sized plates that are constantly moving. How fast are they moving? Pretty slowly, actually. Around 1 to 2 inches per year, which is why it was so hard for scientists 100 years ago to wrap their heads around the idea. So what changed their minds? Well, a few natural discoveries in the 20th century made Wegener's theories seem more plausible. For example, in the 1950s and 60s, scientists discovered heated magma rising up through cracks in the oceanic crust called dikes, which is how new rock or new land is created. This realization that our planet is always reforming and reshaping itself from beneath lent credibility to Wegener's theories. Point Wegener. Not long after, scientists started plotting the location of earthquakes and volcanoes around the world and observed that the location of those events followed a similar pattern to the outline of the plates Wegener proposed. And then there was the fossil evidence. Fossils of tropical animal and plant species have been found in Africa and other places on Earth that are less than tropical. One plausible explanation was that Africa was once part of a larger continent that was home to these tropical plants and animals. Remember Pangaea? So in light of all this evidence, the scientific community started thinking maybe this Wegener fellow was actually onto something, which led to the development of our modern-day plate tectonics theory. So now that we know the history, let's dive a bit deeper into how it all works. According to the plate tectonics theory, these massive lithospheric plates are all moving in different ways, and how they interact with one another can have a huge impact on the Earth. Where these plates meet are called boundaries, and there are three kinds. Convergent boundaries occur when two plates are moving towards one another. Transform boundaries occur when two plates are sliding past one another, and divergent boundaries occur when two plates are moving away from one another. Let's take a closer look at what happens at each of these boundaries. As we said, convergent boundaries are when plates are moving towards one another. When the two plates collide, a couple of things can happen. One of the plates will dive under the other plate. It's usually the heavier, denser crust that dives under the lighter crust. This creates what is called a subduction zone. And the deeper under the Earth's surface that plate goes, the more pressure it creates. That pressure, coupled with a high heat, causes the crust to melt, forming magma. The magma presses up towards the surface, and voila, you've got a volcano. An example of this is the Ring of Fire, which is an active ring of volcanoes that encircles the Pacific Ocean. The other thing that can happen when two plates press into one another at a convergent boundary is the rock above the boundary will be lifted up or folded and form mountains. Ever hear of the Himalayas? That's an example of two tectonic plates colliding. And because the plates continue to move, the peaks in this mountain range continue to grow. For example, Mount Everest, which currently measures around 29,000 feet, grows around an inch every year. So as you could imagine, it takes thousands of years for these mountains to form. But although movement at convergent boundaries is usually gradual, as pressure underground builds, the impact above ground can be quick and violent. Fast movement or slipping of the land can result in earthquakes, either above ground or under the ocean. And convergent boundaries aren't the only type of boundary that can result in earthquakes. At transform boundaries, the Earth's plates are sliding past each other in opposite directions, which creates a crack or fault in the Earth's crust. As the plates try to move, they rub against one another, resulting in the building up of pressure. If the plates are stuck for a long period of time, the pressure will continue to build at the fault line until eventually it releases, resulting in an earthquake. The San Andreas Fault System is one of the largest transform boundaries in the world, which is why that area has more than its fair share of seismic activity. That just leaves divergent boundaries. Like we mentioned before, divergent boundaries occur when plates are moving away from one another. Either the space between the two plates widens and becomes a large crack or rift, such as the East African Great Rift Valley that runs from Lebanon to Mozambique, or if the space between the two plates is under the ocean, where the crust is thinner, magma oozes up from the Earth's mantle and fills the space. This is called seafloor spreading. The Mid-Atlantic Ridge is an example of where seafloor spreading has occurred. The crust under the ocean pulled apart, allowing magma to fill the space between, creating the tallest and longest mountain chain in the world. So in review, the plate tectonics theory is based on concepts first proposed by Alfred Wegener in the early 20th century. It states that the Earth's outer mechanical layer, the lithosphere, is divided into large continent-sized plates that are always moving, leading many scientists to believe the continents we know today were once part of a supercontinent called Pangaea. These plates move 1 to 2 inches per year. Where they meet is called boundaries, and there are 3 different types. Convergent boundaries, where plates collide, transform boundaries, where plates slide past one another, and divergent boundaries, where they move apart. Volcanoes and mountains form at convergent boundaries. Earthquakes and tsunamis can occur at both convergent and transform boundaries. Fissures and large cracks in the surface occur when 2 plates move apart at a divergent boundary. And seafloor spreading occurs at divergent boundaries located at the ocean floor. So that completes our lesson on plate tectonics. As always, feel free to use the scrubbing bar at the bottom to go back and revisit any portion of this lesson.
Now students, I will take some feedback from our today's topic. First question as the feedback of today's topic, and the question is, describe the formation of centrosphere. Answer is below the lithosphere is mantle zone. At last surrounding the center of the Earth is the portion called the centrosphere or core. The spherical layer of about 3,500 kilometers radius from the center of the Earth is known as centrosphere. There are heated nickel, iron, lead, etc. metals in centrosphere. They are in solid state in the outer side and melted state in the inner side of the centrosphere. Second question. What is earth crust? And the answer is the upper portion of lithosphere is known as earth crust. Third question. What is magma? When the plates smack or strike on another, immense heat is produced and the substance inside the earth get melted due to the excessive heat. This melted substance gases out from the below of the earth's surface due to the pressure. This split melted and hot liquid are known as magma. Question number 4. What is lithosphere? And the answer is the interior part of the earth is divided into three layers. Below the earth's surface lies the solid layer covering the interior portion of the earth is known as lithosphere. Question number 5. What is called centrosphere? The spherical layer of about 3,500 kilometers radius from the center of the earth is known as centrosphere. These are the questions as the feedback of today's topic. Hopefully, you can answer the questions by yourself. Those who cannot, please try to memorize the answer of these questions. Students, I will give you some related question regarding today's topic. Please write this related question in your CW copy. Question number 1. What is earthquake? Question number 2. What is volcanic eruption? Question number 3. How can you describe earthquake by tectonic theory? Question number 4. Describe the internal structure of the earth with diagram. These are the related questions from today's topic. You will learn the answer of this related question at your home. And if you did not understand any answer, you can ask your subject teacher during the Zoom class. Now students, open your diary. Today I am going to give you a learn plus write homework. Homework number 28. And the question is, describe the internal structure of the earth with diagram. So students, first of all, you must memorize the answer of this question. After that, you write the answer in your homework copy. That's all from today's topic. Hopefully, you have enjoyed the class. See you in the next class. Till then, stay home, stay safe. Assalamu alaikum.